Hello, and in this video we're going to be reviewing linear functions. Most linear functions that you dealt with in Math 95 or before this were in this form right here, f of x equals mx plus b, where m is the slope, and waiting for the computer here, m is our slope, that's this value right here, and 0b, or b, is our y-intercept. So b would be right here on this graph. It's not labeled, but your y-intercept would be here. To find the slope, we also have the slope equation. Slope equation here is m equals y2 minus y1 over x2 minus x1. So let's take a look at this line right here and we'll do some calculations. Let's see if we can find the linear graph. We would take 2 points on this first of all when we find the slope. So let's take these 2 points and we would use those as, I'm going to start with this one as x1 and y1, and this one here is x2 and y2. And we're going to use this equation here to find the slope. We can see in the graph that the slope is negative. It decreases from left to right, so we should get a negative number here. So we're going to take 20 minus 0 over 5 minus 15. In this case, we're going to get 20 over negative 10. So our slope is negative 2. So we then have the equation y equals mx plus b, or f of x equals mx plus b. And we would plug in a value. Maybe we choose this value right here again. We choose this value again to do y, or f of x equals mx plus b. We would plug in the values. We plug in the values for x and y and m temporarily to figure out what b is. So in this case, if we use this point, y is 0, m is negative 2 from up here, and x is 15. That's going to give us 0 equals negative 30 plus b. So in this case, b is 30. So that means it crosses here at 0, 30. Okay, so that means our equation would be y equals negative 2x plus 30. And in function notation, it would be, in this case it says g of x up here, so we're going to use the term they want. We would write g of x equals negative 2x plus 30. All right, that's just a review of what we would do to find the equation and the slope of the line if we had some points. All right, the second thing we're going to go over here in this section is evaluating functions from a graph. And evaluating functions from the equation, we would just put the numbers in. So once we have these numbers, we can actually figure out the values, right? If we put 5 in for this, we should get 20. If we put in negative 15 in for x, we should get 60. And so on and so forth. But here we're actually asking you to evaluate the functions given that we know the y value, or the g of x value. So they're giving us, we're going to be looking at these values and figure out what x is. So in this first one, it says g of x equals 20. If we scan down the thing until we find 20 for y value, that's this one. So that means x there would be 5 in that case. G of 5, we would say g of 5 equals 20. All right, and then in the next one here, we have g of x equals 60. That would be our first point. There's x equals negative 15, or g of negative 15 equals 60. Now, we also have statements in the book where they're going to ask us for inequalities. So we're going to be asked for when it's greater than a value. So if it's greater than a value, that means the y value has to be higher That means we're going along the y-axis, or the g of x, higher than 20. This says greater than 20, so it's going to be every value that's going to be greater than 5 here. Or actually, in this case, it's going to be all the values less than 5, because all of these numbers are greater than 20, but all of our x numbers are going to be less than 5. So in this situation, we know it happens at x equals 5, but we're looking for the values of the graph. That's this part of the graph that's greater than 20, and we want to look at the x values here where that occurs. That occurs down in these x values. So those x values are actually less than 5. So our answer here is going to be x is less than 5. Or if we wrote it in interval notation, that would be negative infinity to 5. Open interval. Okay, because this is open interval. All right, now if we did the same thing with the next problem, let me erase this part so we can take a look at it in terms of the next problem. So in the next problem, we're being asked to look at less than 60. So everything less than 60. So we're going to take a look at that in black. So here's our 60 value, and we want to be less than. That means we want to travel this direction of the line, because all of that is less than 60 for y values. All our y values less than 60. So that's telling me we're going to start right here at negative 15, and we're going to travel this direction because that's right under our line. So we're going to say x is going to be greater than, since we can be equal to 60, we can also be greater than or equal to negative 15. So in this case, we would have a bracket at negative 15, and we would go to positive infinity up the x-axis. All right. Now in the last example here, we're looking at all the values between 0 and 20. So let's erase this so that I can use a different color for this one. So let's say we're going from 0 to 20 on the y. So when we're looking for 0 to 20 on the y, we'll just use green again. If we're using 0 to 20 on the y, here's 20, here's 0. So it's going to be this piece right here that we're looking for. So it's every x value that's right under it. So it's that x value, which is 5, and this x value, which is 15. So in this case, we're going to be between 5 and 15 on the x's. So we're going to be x. We always put the smaller number on the left, 5 and 15. So we're in between. Now, in this case, it says that we can be equal to 0. So we can be equal to this value here, which is 15. So we're going to be putting our equal to on the 15. See how that switched? Because the 0 value was where we had the 15 value, and in this case we're going to say greater than 5. So basically x is between 5 and 15, but in this case 15 we can be equal to because it can equal to 0. It's a little tricky. All right. Now the last thing we're going to do on this video is look at determining whether a set of points is linear. So when we do that, we look at how we increase here. If the points increase by the same amount on the x, then they have to increase by the same amount on the y value, so we can find the slope. You can also determine the slope by checking a couple values here to see if you have the same. So as long as we're saying our change in our, so what we're doing here is change in y over change in x. For slope, that's another way to think of the slope here. It's change in y, or change in this case, change in f of x over the change in x. So in this case, this delta means change as we say it. So if we look at this, here our change is 1, 1, 1. Every time we're going up by 1 here. Here our change is positive 4, positive 4, positive 4, positive 4. So that means that this is a line, this is linear, because our slope here is a change of this. So in this case, it's going to be positive 4 over 1. This is our slope on this example. Positive 4 over 1. Now if I look at my second example here, in my second example, I still have these increasing by 1, 1, 1, 1, 1. So that means our denominator is going to be 1 in every case. But in this case, if we look at this increase, we're increasing by 1/4 here. Here we're increasing by 1/2. Here we're increasing by 1. Here we're increasing by 2. So that means the first slope is going to be 1/4. My second slope is going to be 1/2 over 1, which is 1/2. This is 1/4. This is 1/2. My next one is going to be 1 over 1, which is 1. And then my fourth one is going to be 2 over 1, which is 2. Now these are not the same, so since they're not the same, it's going to be not linear, because our slope, our rate of change is not going to be the same. So that's just a review. That's looking at a few examples in the book. If you have any questions, give me an email.